Hi friends, we'll solve problem on kinetics of particles 3. You see what is given in problem. Block A is released from rest in the position shown and slide without friction until it strikes ball B of a simple pendulum. Knowing that coefficient of restitution between A and B is 0.9, determine velocity of B immediately after impact, the maximum angular displacement of the pendulum. That means what you know, coefficient of restitution is 0.9. Number 1, block A is released from rest, that means its initial velocity is 0 and it slides without friction and then it strikes a ball B of a simple pendulum. You have to find out velocity of ball B immediately after impact and maximum angular displacement of pendulum. So just see figure which one is given in problem on next page. Body A, this one is a block A which starts its motion from rest, which one slides along this frictionless surface, then it strikes ball B of simple pendulum. You have to find out what is velocity of ball B just after impact and then maximum angular displacement. Length of this pendulum string is 0.9 meter, and when this block slides along this curved surface, this one is quarter circular, this dimension is 0.6, this vertical is also 0.6 meter. That means this one is a case where block starts from rest. Now when it moves along this curved path, again its potential energy decreases and kinetic energy increases. And motion is without friction. Therefore, when this block slides through this much height of vertical displacement is 0.6 meter, it attains what velocity is velocity of block just before impact. And this velocity will get using law of conservation of energy, which one, as per that law of conservation of energy, velocity of this block just before impact is root of 2gh. That means VA, if I'll write, is what? Velocity of block just before impact, which is root of 2gh. That means VA, if we'll find out here, which one comes out to be root of 2 into 9.81 into through what height it falls in downward direction to 0.6 meter. Therefore, what velocity you are getting here is root of 2gh, and this answer, if you calculate using calculator, this value comes out to be 3.431 meters per second direction rightward. What about this ball of simple pendulum, that is VB? Initially this ball is at rest. Pendulum bob is at rest. Bob is at rest. Velocity of this bob is what? 0. You know coefficient of restitution is given in problem, that is E equal to what? It is 0.9. Coefficient of restitution between block and ball is 0.9. You know mass of ball and mass of block, right? Mass of block is 1.125 kg, mass of bob is 1.8 kg. You know coefficient of restitution and you know VA and VB. That means applying law of conservation of momentum and coefficient of restitution, we are interested in velocity of bob of a simple pendulum means what? VB dash. If you will apply law of conservation of momentum, which one is MA VA plus MB VB equal to MA VA dash plus MB VB dash. Now MA is 1.125, VA is 3.431, rightward means positive, plus this term becomes 0 because velocity of bob of a simple pendulum 0. Next one, MA means 1.125 VA dash plus 1.8 VB dash. That means what we'll get here, one relation 1.125 VA dash plus 1.8 VB dash equal to, that means 1.125 into 3.4 something, 3.431. If you multiply here, what will get here, this relation equal to 3.86, say equation number 1. Once you get this equation number 1, next part is what, will apply coefficient of restitution equation, where coefficient of restitution equation is E equal to minus of VB dash minus V dash upon VB minus VA. Next equation, coefficient of restitution E equal to minus of VB dash minus V dash upon VB minus VA. Therefore, E is what, 0.9 equal to, now VB dash and VA dash, these are unknown. VB, velocity of bob of a simple pendulum, 0, minus what you have calculated, this VA value is 3.431. That means using this one equation, we'll get VB dash minus VA dash equal to minus, here 0.9, here already minus sign, minus minus will get what, plus, and finally what will get here, VB dash minus VA dash equal to 3.087. This is equation number 2. Now solving equation number 1 and 2. Equation 1 and 2, if we solve, we are interested in what, VB dash is asking problem. What is the velocity of bob of a simple pendulum just after impact? Value comes out to be 2.507 year meters per second. Answer positive means right word. This is our first answer. Once you will get this velocity of this pendulum bob, right? This one is answer. You have to find out what next part is, a maximum angle of swing of pendulum bob. Therefore, just see here what is given, or in figure what we are represented. This length is 0.9. That means this length is also what, 0.9 meter. Now this bob after impact moves with this velocity VB dash, which we have calculated just now, which is equal to 2.507. Now as this pendulum swings, pendulum string you can say rotates like this, it moves above the ground, away from ground. Therefore what happens, potential energy increases, kinetic energy decreases. A stage may reach where velocity of this bob becomes 0. When it becomes 0, again it moves in downward direction. When velocity of this bob becomes 0, say this height what it attains is h. Now velocity becomes 0, it attains some height h. That means what angle we'll get here is what, maximum angle of swing, theta max. What is the relation between VB dash and h is what, VB dash equal to root of 2gh. Now if I'll construct here a triangle, I'll represent separate diagram for this one so that you will understand. Say this point is what, O, what point you are getting, B, and this one is say B dash. This one is point O, what you are getting here, point B. Now it swings, what you are getting, B dash in new position. Maximum angle of swing is theta m max. Now this one line if we construct here, if we draw a line, what we will get here, at this height what it attains is say h, so this length becomes 0.9 minus h, because total length of pendulum string is 0.9 and this one is also what, 0.9 meters, or to what, B dash. Relation between this VB dash after impact when it attains velocity of VB dash and h relation, applying what, law of conservation of energy, VB dash equal to root of 2gh. You know this value is 2.507. If we take its square, so you will get this h is possible. From this one, if we find out this height h, this height h comes out to be 0.32 meters. Once we will get height h, now this angle is maximum angle of swing. In this triangle, say point N, triangle ONB dash, you know ON and you know what, OB dash, adjacent and hypotenuse. In triangle ONB dash, you know adjacent side, you know length of what? Hypotenuse. That means if you use cos of this theta max equal to adjacent is what? ON, hypotenuse is what? OB dash. Therefore, what will get here? ON length is what? 0.9 minus h divided by OB dash is what? 0.9 meter. Therefore, cos inverse of this value, if you will find out, you will get what? Maximum angle of swing, and this one comes out to be 49.87 degrees. This one is our final answer. Thank you.